So I have on the board here a linear first order differential equation. And the first thing I want to do is I want to get this in the right form. And let me show you what that is. So we want to get this into the form dy dx plus p of x, which is some function of x, y equals g of x. And this will be our form for a linear first order differential equation. So what I need to do is take this equation up here and divide it by -3. And we're going to have dy dx. Oh, that's kind of terrible to have plus minus together like that. All right, I'm going to overlook that. Hey, look at that. I should see if I can scribble this out in yellow and make it look like it never happened. You can totally see what I did. I don't know why that was there. All right. Anyway, we'll go forward. Gonna overlook that. Okay, we divide by -3 and we get plus 4y equals -4. And then what we're gonna do next, we want this. What I'm gonna multiply through by u. I'm not gonna go through the background too much. And so when I do that, what we're trying to do is get this into a form where it looks like the product rule on the left side. And what I mean by that is if we had, whoops, if we had u, y, and we took the derivative, we'd have to use the product rule, and we would get u, y prime plus u prime, y. And notice that that looks an awful lot like this, with one big difference. That doesn't quite line up. So what we can do is we'll make it line up. We'll set these two equal. We'll set u prime equal to 4u and solve it. And that's how we're going to make this work. So I'm just going to write this out so we can do this as if it's a little separable differential equation within our larger differential equation. And we'll just divide by u and multiply through by x so that we get this into a little different form. I'm just going to bring it over here just because I like it that way. We're going to end up with du over u dividing by u. And then on the other side, we're going to have 4 dx. Integrate both sides. We'll have ln of u equals 4x. And then therefore u equals e to the 4x. Okay, then going back, what we can do is, since using this equation, we can write the whole left side as u, which is e to the 4x, times y. The derivative of all that is going to equal, and then our right side is minus 4u, which is going to be minus 4 e to the 4x. And then all we need to do to solve this is just get the derivative on both sides. So let's see, we'll take the derivative, end up with, oops, we'll end up with e to the 4x y equals minus 4 e to 4x, but we need to use there's the chain rule going on, so it's sort of like we'll do a quick u substitution in our head and bring down this 4. And then what we can do then is divide both sides by e to the, oh, I forgot my plus c, that's important. So we got our e to the 4x, e to the 4x that we'll divide on both sides. That didn't look right. E to the 4x. And so what we're left with is y equals, this whole piece is just going to be -1 when the e to the 4x cancels. So we have -1 plus c e to the -4x, just bringing this up to the numerator. Don't forget to divide the c by the exponential from the other side. That's one thing that's a little different. People are accustomed to just writing plus c if they're doing an integral. And then that's going to be our final solution. So, and then we didn't have any initial conditions. If we had initial conditions, we could plug it in, solve, and find our value for c. All right, let's just do it. We'll do initial condition real quick just to do it. Let's say if we were given this. So what that means is we're saying y is going to be 2 when x is 0. So all we'll do now is just y is going to be 2, and we just need to plug in 0 over here. Looks like 40. Let's not do that. Minus 4 to the 0. But then e to the 0 basically is just 1. So we end up with minus 1 plus c equals 2. We'll add a 1 on both sides, and we end up with c equals 3. And then so pretty easy to go to the initial condition problems. Then we can just rewrite this whole thing. We'll rewrite it as, we now have our value for c, so we'll write it as y equals -1 plus 3 e to the minus 4x. And we're done.